Welcome everyone, and thank you to Donna and the MEGWA committee for inviting Rumble Resources tonight to introduce the Earaheedy Zinc Lead project to everyone. Very kind of Donna to suggest this evening, the night of the AGM, to ensure some people turned up to listen to a talk about zinc. As the title suggests, tonight's talk will focus on the 46-year history between the first recognition of galena and pyrite in outcropping dolomite to the announcement of a maiden resource in 2023. The second part of the talk will introduce the unique natural upgrading of the new Dissolution breccia that hosts the majority of the current resource. But before talking through the discovery history, I'd like to talk about how Rumble Resources came to be looking for zinc and lead in the Earaheedy Basin. Year zero for Rumble Resources was November 2016, when Brett Keylor joined the board as technical director. For people that don't know, Brett is a rare combination of a highly technical critical thinker across scales, which makes him both an excellent project generator and economic geologist. He's also a true gentleman who's a pleasure to work with. Brett has twice been awarded AMEC Prospector of the Year. The appointment of Brett to Rumble signalled a change with rationalisation of the existing Rumble tenure and a clear focus on the search for potential Tier 1 projects. The high price of gold assets owing to market conditions at the time led to the pursuit of other commodities with lower price expectations for projects. MD of the time, Shane Sikora, was very active in presenting hundreds of projects before Brett to review at this time. The main threshold for any new project was that it must have a substantial metal budget over large continuous areas. This process ultimately led to Rumble acquiring the Braeside project in March of 2017, followed by the Earaheedy project in October. The Earaheedy project has several key attributes that immediately raised Rumble's attention. MVT mineralisation was recognised in carbonates at many locations, the regionally extensive carbonate host for the mineralisation, the laterally extensive shallow dipping stratigraphy allowing for large-scale systems, and several prospects host significant grade to support a robust metal budget. Almost half of historic drill holes did not intercept the target horizon. All of these features created an opportunity to test the prospective horizon where previous attempts had failed due to difficult drilling conditions. Low zinc and lead prices at the time presented an opportunity to enter the project where exploration efforts had moved elsewhere. The project's located approximately 110 kilometres northeast of Wiluna in what I often describe to the spatially unaware as the geographical centre of Western Australia. Access is straightforward via sealed roads to Wiluna, then gravel along the Neds Creek Road and station tracks inside the Kunyu pastoral lease. In what a project requiring possible concentrate shipment lacks in proximity to the coast, it gains by being close to the Goldfields gas pipeline and major sealed roads. Tonight's talk is focused on the unique attributes the new Dissolution breccia hosts, but it's important to give a quick introduction to the published geology of the area to explain how the metal came to be there in the first place. The Earaheedy Basin opened in a passive margin setting during the collision of the Yilgarn Craton and the Glenberg terrain during the Glenberg orogeny. Zinc and lead occurrences along the southern margin of the Earaheedy Basin are recognised as MVT in origin, owing to their dominantly stratabound style of sphalerite, galena and pyrite within carbonate host rocks, their low temperature mineralising fluids and location along the edge of a known sedimentary basin. MVT mineralisation in the Earaheedy Basin is recognised as some of the oldest globally. Work completed in the past 10 years has confirmed that the carbonates that host this MVT mineralisation are coeval with the continent-continent collision farther west, marked by the Capricorn orogeny, the period in time when the Pilbara Craton collided with the Yilgarn Craton. The next slide focuses on the project geology around Chinook and Navajo. Over 30 kilometres of strike separates the known extent of mineralisation at the Earaheedy project between the Marto prospect and the resource area of Navajo in the southeast. The Yelmer formation presented here as the blue, purple and grey consists of two dolomite sequences separated by the Chinook Shale. The mineralisation in the area, the Iroquois dolomite is the oldest and thickest of the carbonates, whereas the Sweetwater Well dolomite is the youngest and thinnest and hosts most of the known MVT mineralisation in the area. The carbonates and the fine-grained siliciclastics of the Yelmer Formation are strongly recessive in the landscape. The Frere Formation, illustrated here in orange, varies from siltstones at the base to granular iron formations higher up, which present as the resistive Frere range. Dating supports a 20 to 40 million year hiatus in sedimentation between the Yelmer and Frere formations, known as the Navajo unconformity. The Lockridge Fault is the most significant structure in the project. The fault is the northern limit of the Celia lineament that persists some 600 kilometres to the south. The Nabaroo Lake system, which follows the upper contact of the Yelmer Formation with the Frere Formation, continues along to the southeast. There is one outcrop of dolomite within the project area, the location where BHP geologists would first recognise the potential for sedimentary hosted zinc-lead here at Sweetwater. BHP arrived in the area in 1975 after reports that station wells had been abandoned in manganese in the area of the #1 bore on the Canning Stock route. Further work considered the Earaheedy Basin to have similar characteristics to the Hamersley Basin, which led to investigation into the iron potential. However, despite much mapping and some drilling, the iron and manganese potential was deemed to be low. Then, in 1977, BHP geologists discovered galena and pyrite stringers in stromatolitic dolomite at Sweetwater, what would be recognised as the only outcropping dolomite in the area. It's a great place to visit to see the abundant stromatolites and outcropping base metal mineralisation adjacent to the narrowing of the Nabaroo Lake drainage. 6 holes were initially drilled adjacent to the outcrop, with only 3 penetrating the dolomite horizon. Best results of 1.6% lead in SW3 within a broader 20 metre thick interval greater than 0.1% lead highlighted there was potential for base metals in the area. The company had difficulty arriving at a drilling target from 1 to 25k mapping and prospecting owing to the recessive shales and dolomites of the Yelmer Formation. Lead isotope work supported that the mineralisation was syngenetic in origin. Further percussion drilling and 3 diamond holes failed to generate any significant mineralisation, leading to the drop of all tenements in 1979. The area then remained open for some 16 years before Caladium Mining pegged ground in 1993 to search for diamonds, following on from work by CRA in the area. Renison Goldfields Consolidated, or RGC, then pegged along strike and JV'd the Caladium Mining ground as part of the broader Teague project, focused on the search for 200 million tonne MVT camps in the Earaheedy Basin. At this time, RGC were a large, multi-site, multi-commodity mining and exploration company. Initial work focused on the southern margin of the basin, along strike from the area recognised by BHP along here. 42 RC holes were completed in the first field season of 1994, with the best results at Iroquois and Navajo. 13 diamond holes then were drilled to follow up on the best of the RC results. Best results returned from drilling at Navajo with 7.3 metres at 6.89% zinc lead in PDH4. Then in 1995, the field season was interrupted by a major rain event with access not possible between March and August. 47 holes were completed in 1995 in total. Drilling was more aligned to the current resource area, recognising the Sweetwater's dolomite member as the prime host. 5 holes intersected greater than 0.5% zinc lead, but the best grades were dominantly on the unconformity. The grades were also too low for the perceived and targeted 200 million tonne exploration target of an ore body suitable for underground mining. Despite the success of these select intercepts, many holes failed in mineralisation or to test the host. The failed drill holes were due to the lower air capacity of early percussion drill rigs. RC hammers had been developed for 5 years or more. However, typical rigs at this time were less than half the air of modern RC drilled today. The lower air would simply not hold back the high influx of groundwater, resulting in the hammer not firing and the holes having to be abandoned. The company had major success at the western end of the Earaheedy Basin on Paru Station with the discovery of Magellan, a presumed oxidised lead relic of a former MVT deposit. 1996 was the final year that RGC tested the Teague project in the Earaheedy Basin. Diamond drilling was completed around the known prospects and further northeast into the basin. The best intercept was 6 metres at 4.92% zinc lead from the Navajo prospect. Without evidence to support a large potential underground resource, RGC abandoned the project and dropped the ground in 1997. 10 years would pass at the Earaheedy Basin before another explorer pegged the ground. Zincco, listed in 2007 as a spin-out of Euralia Resources, who pegged the ground over the Earaheedy project, recognising that the best intersections are aligned along faults. To better map faults, Zenith flew aeromagnetics and completed a structural analysis that supported the premise that the best mineralisation correlates with the intersection of structures. Zincco drilled 250 metre step-outs from the RGC mineralised holes for a total of 660 metres. However, due to the drilling capacity constraints of the drill rig, only ZTRC 003 intersected the target zone. This hole terminated in mineralisation with 10 metres at 0.7% from 146 metres. 2009 was the start of waning interest for zinc for Zincco, with only surface prospecting completed along the Lockridge Fault before a pivot into manganese. A high-grade manganese discovery was made in February of 2010 in younger siltstones above the Frere Formation. No further zinc exploration was completed until 2017. Rumble optioned into the main tenement for $550,000 in cash and scrip to earn a 75% interest. Rumble recognised that mineralisation zonation was not modified by later faults, that bedding parallel faults may be a significant mineralised fluid conduit, and that the intersection of the transfer faults and bedding parallel faults are higher order exploration targets. Partial leach soils were completed to test for potential leakage up faults, and gravity was collected as a potential direct detection tool and to map the blind iron poor Yelmer formation that remained featureless in the aeromagnetics. Rumble was also a successful recipient of EIS funding to test this breccia host model at Earaheedy. By early 2019, data from the gravity survey confirmed denser rocks along the interpreted basement faults. A small drilling program was completed to test the gravity anomalies. Chris Vollmer, formerly of PXD Drilling, agreed to come out to Earaheedy, which was a long way from where he was, and drilled 2 holes to establish that RC drilling could in fact be completed successfully in the ground. The next slide is a section completed through Navajo down here in the bottom of the screen. The results from the maiden drilling program were encouraging, with 4.7 metres at 2.81% zinc lead from 153 metres in EHD 004 and 7 metres at 2.51% in EHRC 001. However, the mineralisation was not breccia hosted on a fault, but stratiform within a grit facies on the unconformity between the Yelmer and Frere formations. A review of holes that tested the unconformity confirmed that the mineralisation was widespread along this horizon. Published dating had a 20 to 40 million year hiatus between the Yelmer and Frere formations. The working model was that the terrain was karstified and that mineralisation was mobilised into sub-basins along the unconformity. Encouraged by the recognition of scale, Rumble published an exploration target of 12 million tonnes per kilometre of mineralised unconformity. A program of 19 RC holes was completed at 500 metre spacing to further test the concept. The best result of 11 metres at 4.13% zinc lead from 61 metres in EHRC 019 at Chinook confirmed the tested model and gave people confidence to do further work. On the back of the exploration success at Chinook and Magazine, a revised exploration target of 40 to 100 million tonnes at 3.5 to 4.5% zinc and lead was published. However, despite the scale and the shallow depth of mineralisation, there was little corporate appetite at the time to pursue the project. An RC rig finally returned in March 2021, aimed at drilling 500-metre space lines across Chinook and Magazine. The program was a great success, with the return of the thickest intervals closest to surface yet drilled at Chinook. 34 metres at 4.22% zinc lead from 66 metres and 21 metres at 4.31% zinc lead from 61 were highlights of the program. At this point, Rumble went into true discovery mode, with the following 2 years spent with up to 6 rigs for a total of 600 RC holes and 30 diamond holes. Rumble released the pit-constrained maiden inferred resource in April of 2023, 94 million tonnes at 3.1% zinc lead at a 2% cut-off. Best zinc and lead contouring illustrates some of the strongest continuity along the Calatarn and Chickaman fault zones, with the resource remaining open in many directions. It's taken 46 years from the discovery of outcropping galena at Sweetwater's Well to the publication of a maiden resource. Where to from here? Rumble's maiden resource remains open in many directions, especially around the feeder faults of Colorado, Calatarn and Chickaman. The discovery last year of Marto, some 30 kilometres along strike to the west of the Navajo resource, signals the potential for further mineralisation along strike in what is already a large camp. The Earaheedy project is a shallow, large, lower grade zinc and lead resource. Rumble needs to demonstrate the metallurgy to recover the metal economically. Current work is focused on beneficiation and ongoing flotation studies to both increase the resource grade through a potential plant and unlock the broader resource at potentially lower grades. What are the key takeaway points from Rumble's exploration at Earaheedy? That modern RC drill rigs with a greater air capacity permitted the rapid and economic scoping of mineralisation. The collection of gravity data early in the discovery history allowed Rumble's geologists to map the non-magnetic Yelmer Formation host rocks and to target in on the faults that control grade. The unconformity-hosted sphalerite and galena mineralisation has been a constant source of investigation for Rumble. Earliest thoughts were that it was a grit, then a marl, and now most recently a dissolution breccia. The second part of the talk will describe the new dissolution breccia host and outline the current genetic model for its formation. Now that we've discussed how Rumble got to where we are, I would like to talk about the geology and why the host of the zinc and lead mineralisation is so unique. As discussed earlier, the Yelmer Formation is the basal formation to the Earaheedy Basin. The carbonates and fine-grained siliciclastics are strongly recessive in the landscape. The Yelmer Formation consists of 2 dolomites separated by the Chinook Shale. The upper dolomite is the host of the majority of the known MVT mineralisation. The top of the Sweetwater dolomite member is marked by the Navajo unconformity before the younger siltstones and granular ironstones of the Frere Formation. Earliest Yilgarn faults have been important on the development and deformation of the Earaheedy Basin. The cilia lineament that persists to the south persists as the Lockridge Fault through the centre of Chinook along the Calatarn feeder zone. Reactivated basin growth faults and orthogonal transfer faults are also important controls on grade. Mineralisation at Chinook, Tonka and Navajo are principally hosted in the new dissolution breccia immediately below the Navajo unconformity. The next slide is a section through Chinook across the Chickaman zone. Lots of information to take in here. Key points to take away are to do with the new dissolution breccia. My role tonight is to explain to you that the host unit to mineralisation is the product of dissolution of the uppermost carbonate unit. Grades within the new dissolution breccia are higher due to volume loss of the gangue, leaving the sphalerite, galena and pyrite behind. The new dissolution breccia occupies the position at the top of the Sweetwater's Well dolomite on the Navajo unconformity below the Frere Formation. The most striking feature is the attenuation of the Sweetwater's Well dolomite down dip towards the northeast. In this area, the clean carbonate unit is completely absent up dip towards surface and reduced in thickness by more than half elsewhere. Immediately above the new dissolution breccia shown here in the dark tan above the yellow, is the collapse breccia, present as a weathered, poorly sorted breccia of angular siltstone class of the Frere Formation in a matrix of weathered siltstone. As the name suggests, the collapse breccia is interpreted to have formed by volume loss during dissolution of the Sweetwater's Well dolomite. Although mineralisation is still present through much of the dolomite in the footwall, the bright colours reflect the higher grades within the new dissolution breccia. Zinc typically outnumbers lead 3 to 1, but can be as high as 10 to 1 in zones such as at Tonka. Across the project, we see the Frere Formation weathered above the new dissolution breccia. The new dissolution breccia is absent down dip below where the Frere Formation is fresh. As the majority of the drill holes are RC, stratigraphic offsets of the otherwise consistent 7-degree dip to the northeast are the main mapper of faults. The Chinook Shale is the perfect marker unit. No geologist can fail to identify the distinctive purple unit as the right time to end a drill hole. Now that we've seen the context for where the ore hosting new dissolution breccia occurs, it's finally time to look at some rocks. 2 end-member lithofacies are recognised within the new dissolution breccia. The siderite breccia is competent rock and straightforward to drill. Fresh sphalerite, galena and pyrite are present as vein fragments, blebs and disseminations. The siderite breccia is polyphase with evidence of class within class supported by a siderite gang. Relic marine cements and quartz vein fragments are supported by a siderite breccia matrix. Unlike the siderite breccia, the dolomicrite has a loose, unconsolidated consistency and is challenging to recover with a diamond drill rig. Equal to the siderite breccia, the dolomicrite contains fresh, crystalline sphalerite, galena and pyrite supported by a matrix of silt to gravel sized impurities. The dolomicrite also contains relic marine cements and quartz vein fragments. Importantly, the dolomicrite cross-cuts the siderite breccia and as such is considered youngest. Looking in more detail at some examples of the siderite breccia, we see that the sulphide textures are identical to those described in MVT dolomite-hosted mineralisation. The sulphides are mostly coarse-grained and quartz vein fragments are common. Local internal sedimentation represents siderite reprecipitation within former cavities. Small cavities are also common. Darker siderites are manganiferous and more common paragenetically older than the lighter coloured, less manganiferous siderites. The siderite breccia has very low calcium. The absence of stylites and unfilled porosity are not consistent with a Paleoproterozoic age for this rock. The top photograph is taken of a tray of core from a sonic drill hole. It presents the closest representation of what the dolomicrite looks like in situ. The saturated and unconsolidated mixture contains both unbroken blebs of sulphides with the same textures as the siderite breccia. Class of siderite breccia are common. Calcium is below detection. The second photograph illustrates an example of siderite breccia with a clear earlier siderite class. Much easier to see when it's been oxidised for a bit longer, with a dissolution gradient on the scale of tens of millimetres from competent siderite breccia to dolomicrite facies. These textures point towards a continuum of fracture-controlled, anoxic, weakly acidic and reduced fluids dissolving the siderite breccia and leaving the dolomicrite as the relic product. Textural features support the interpretation that the new dissolution breccia is the product of dissolution of dolomite-hosted MVT mineralisation. Rumble set about gathering further information to understand the conditions of formation. Lead isotopes are a common technique to date mineralisation. Samples of sulphides from across the project within the new dissolution breccia are in agreement with samples collected from MVT mineralisation. All samples are on the outer growth curve, indicative of an upper crustal source consistent with an MVT origin. Lead isotopes from galena support a model age of 1850 to 1810. Some samples occur on a very flat isochron indicating mixing with a high uranium younger source. Does this age represent the actual age of the new dissolution breccia, or simply a closed system of 1.8 billion years? The question still remained as to the age of the siderite within the new dissolution breccia. 3 samples of siderite were analysed with the TIMS at Curtin that support the Paleoproterozoic age, albeit with a mixing trend towards a younger source. Stable isotope values of the new dissolution breccia were collected from both siderite matrix and internal sediments. The 2 siderite populations returned consistent values. When compared to other stable isotope results, the Earaheedy siderites returned oxygen isotopic values consistent with modern pedogenic dolomites. Armed with this further support for the young origin of the new dissolution breccia, rumble geologists set about reviewing the geological model given the new constraints. So to review what we've learned so far, there is strong textural evidence that supports a much younger age for the new dissolution breccia. The spatial extent of the new dissolution breccia is coincident with where the overlying Frere formation is weathered. The new dissolution breccia lead ages are confirmed at 1850 to 1810, consistent with the MVT proto-war. Some lead isotope data in galena and siderite indicate a mixing trend towards a younger source, and oxygen isotopic values are consistent with modern dolomites. So what does that actually look like? Rumble has put together this 4-stage cartoon to help walk through the development of the new dissolution breccia. Starting at the top and working to the bottom, earliest preconditioning, sedimentation during sag in a foreland basin setting to the Glenberg orogeny with reactivation of normal faults. Then around 1850, 1810, MVT mineralisation during the Capricorn orogeny. Metal-bearing connate brines migrate up pre-existing fault arrays and precipitate sulphides in reactive and dilatant positions via fluid mixing. Some 1.7 billion year hiatus then separates this MVT mineralisation with the new dissolution breccia. During the Cenozoic, deep weathering during warmer, higher rainfall conditions generate reduced weakly acidic fluid that dissolves dolomite-hosted MVT mineralisation gangue and reprecipitates siderite gangue around sulphides and relic quartz marine cements and vein fragments. Continual acid fluid generation redissolves siderite gangue and reprecipitates siderite as a multi-phase breccia with evidence of internal sedimentation. Finally, the supply of acid fluid ultimately exhausts acid buffering ability of the siderite breccia and dissolves siderite into what is recognised as dolomicrite. The spatial distribution of dolomicrite is almost universally along the base of the new dissolution breccia, but can occur anywhere within the siderite breccia of the new dissolution breccia. Discovery of Earaheedy is the result of the recognition of a large metal budget, assumption of a model to test, and then adjustment to a new unconformity model based on drill results received. Modern RC drill rigs permitted efficient drilling through challenging ground to rapidly scope mineralisation. The development of a genetic model for the new dissolution breccia accelerated with the production of core, a curious and motivated team, and the help of subject matter experts. Future work within the large project footprint will look to confirm and optimise the excellent flotation results and potentially upgrade the massive lower grade mineralised envelope through beneficiation methods, whilst also targeting the open high grade extensions and newly delineated discoveries such as at Marto. Thanks very much.